old files, sorry, are the old files removed from the, because I did see that part of the program, so are the old files removed from the list, or are they just marked with the hashtag and then they're considered already read?
Just marked with the hash.
Okay.
So this is all the GUI at the very beginning. And then the method load form actually starts up the program itself, all the logic behind it. So what load form does is it selects the config file, or it gives a pop-up to select the config file, so you can choose which version of the config you want to use. So in case there are multiple versions, we can just choose the right XML file, and that XML file will be your parameter set for the rest of the time.
So Judson.
Okay, so what's specified in the parameter file?
The parameter file has everything necessary to make it all run. It has the location of the files, it has the location of auto search, and it has a lot of the methods and parameters needed in auto search and in auto load.
Okay.
So when you first start it up, you'll have a new pop-up for selecting a config file. And while the parameter is still being selected, the auto update program will actually freeze. It won't run until the param file is set. Once the param file is set, auto update will set itself to visible and start running. So then what we do is we set up the finished sample list, or we set up the sample list, which is the table you see when you run auto update of samples and whether or not they've been run or not. So samples to run is a new vector that hangs on to all of the samples that have yet to be run through the pipeline. And sample list path is the actual path of the finished sample list. So the list, the text file that has all of the sample names and the hashes.
Could I jump in here? So, Judson, have you actually seen the config file in the finished sample list before?
No, I haven't.
That might help. It'll be hard for him to understand, Naveed.
Yeah.
Maybe can you pull that up real quick?
I should still have it. Let's see. So this is an example of a configuration file. I don't want it to open Xcode. Okay.
Okay, and the sample list file is just, alright.
Yeah, so this is just the XML file that has everything. So like where Sequest is located, the port we should connect to Sequest on, the identity of this client, and if we go down to that one, it has all the information for the current client. And then if we go to a finished sample list, it's literally just all the samples.
You should go through it. So,
Yeah.
So basically you've got the path to the raw file, the type of instrument, m: means mascot search. This is the name of the mascot param file. It specifies the parameters of the mascot, username, and the method used to collect the data on the instrument. And this SQ:, so that's sample queue unique identifier from FileMaker. So we have a sample queue in FileMaker that describes data acquisition parameters. And so to get access to all those, you just have to put the unique identifier there. Does that make sense, Judson?
How does it now? This is before the data has been in FileMaker though. So where does that come from?
Well, so actually the way this works is we collect data on a Visual Basic program called LTQ Automate, and that program connects to FileMaker sample queue and allows the user to select the samples that they want to run. And so at the moment that the user selects that sample, it not only provides the parameters to run the sample, but also provides this unique identifier. And that ends up in this finished sample list. So the LTQ Automate program actually, there's another program called Auto, or actually LTQ Automate, Naveed, adds to this finished sample list. So afterwards, after your run has been acquired, a new line is appended to finished sample list from LTQ Automate. Does that make sense?
Okay, so this is triggered from FileMaker then. Automate will be.
No, it's triggered from a Visual Basic program called LTQ Automate. It's basically the data acquisition software we use on the mass spectrometer, which connects to FileMaker, gets the information from FileMaker, but you're actually running the data acquisition in LTQ Automate, not in FileMaker.
Okay, I see.
Okay. So these are the parameters that are specified. Because after we're done analyzing data, one of the analysis steps is to upload the data to FileMaker, and during that upload process, it's helpful to have those sort of pre-data acquisition metadata to link up to the newly analyzed and database loaded data. So, okay, does that make sense?
Yeah, I think that makes sense.
Okay, so maybe go back to config, Naveed, real quick. Yeah, so in this thing, basically, you have the initial section which talks, so there's different computers that are involved in the pipeline analysis. So there's the mass spec computer. There's a computer called Auto Search that runs a program called the Auto. It's actually the computer's name is Sequest, confusingly, and it runs a Naveed's program called Auto Search. And then there's a third computer called Loader, which runs Naveed's program, a second Naveed program called Auto Load. And so each of those programs, so we have Auto Update, which is on basically the program that sits on the mass spec that pushes the data to Auto Search. So all of these programs, Auto Update, Auto Load, and Auto Search, have the same config file. So some of these config file settings are specific to each of those computers, and some are sort of universal.
Okay.
So do you think it would be helpful to go line by line through this, Naveed, or what?
I think method by method would be the best way to go through it.
Okay.
Yeah,
I think I've commented it pretty well, but if you have any questions, just of course, just ask me.
All right, cool. So continue on.
So if we continue, we're going to find the finished sample list from the params. And then, once we have it, we build the sample list. So let's go to that method real quick. I think it's down here. Where is it? Okay, here's build sample list. So, yeah, this method basically just reads in all the data from the finished sample list and only retains the ones that are non-hashed, so that have yet to be run. So what we do is we clear the samples to run list, and we find so we read all the lines in the finished sample list, and we find all the ones that are either errors, so they have double hash, or the normal ones that don't have any hash on them that have yet to be run, and we add those to our samples to run list. We also add them to the table so that you can see them in the visual interface.
Okay.
And then we just reverse the table for the display purposes, so the most recent ones to be run show up on top. So let's go back. So that's that. So once we build the sample list, we connect to Sequest, or we try to. And if we only connect to Sequest if we have a sample to run, and if we don't have a sample to run, we check the sample list again, and we go to sleep for a minute. And then we basically run this entire loop over again every single minute. If we have something to run, we run it, and if we don't, we put the thread to sleep. So let's go to send to Sequest, which is our next method. So this method sends all the data to AutoSearch by first creating a socket to connect to AutoSearch, and then sending over the files and the file name and everything involved with getting everything to AutoSearch. So first thing we do is we open up a new socket by finding the computer name or the location for Sequest, which we can get from the param file. So it defaults to whatever the second parameter is in the method for get global param, but we should be able to get the Sequest computer from the param file. And we also then get the port that we want to connect on. So the socket won't connect unless the computer name and the port are reciprocated on both computers. Then, once we have that, we open up the input and output streams so that we can read and write on the socket. And then we write to the socket. So we first write ready to see whether or not AutoSearch is currently running a sample, or if it's free to take up another one to run on Sequest. So then we read in what Sequest or what AutoSearch sends back to us, and if it sends back ready, then we start sending it all the files. So we send it the sample, which is just I guess when we pop from the vector, it's whatever's at the top of the vector. Where did we get that file to send? So right here at the top, we get the file that we want from samples to run, and we send the file name over to AutoSearch, so AutoSearch can then parse everything in the file name, and then we also send it all the data using push files. So let's go look at that real quick. So here's push files. It basically sends all of the data to AutoSearch over the socket in little packets, and then it returns true once it's completed. So it will find the path, the local path where all the files are stored, and then it will iterate over the directory stream. So the directory stream basically is a way to get a list of all the files, and I have it so that there's a filter that only searches by file name. So in files right here, this is a list of files that match the file name in that folder. So whatever the sample name is, it only has those samples in that list.
Where's the folder, Naveed, where's the folder specified here?
So the folder specified in the param file.
Okay. But then it's not just the param file, there's going to be sample-specific folders, isn't there, for where the files are stored?
Yes. So we get that from in this finished sample list, the file name that's in the finished sample list also has the location of the current file. So if we look back at the finished sample list, it's stored in f/Excalibur/data ... all the way to here. So if this is the last file, this is the file location.
I lost screen share for you. I'm not getting any updates. Oh, there it is. Never mind. It's working now.
Okay. So that's where we can get the file location, the file path. And then this
Sorry,
is
can you say that one more? Can you say that one more time? So you get part of the path from the param file, but then the sample specific folder. Can you say again where you got that?
Yeah, the sample specific folder is in the finished sample list.
Okay.
So if you see on my screen, I'm going to highlight the location. So f:/Excalibur/data/Solomon, etc., etc. That's the location of the specific sample we're looking for.
Got it.
That seems fully qualified, though, Naveed. What are you? So
It
what are you
is.
getting from? This is a confusing part, I think.
So what I get from the param file is the base path, is what I call it here. So in the param file, if we look back at core and local path, we get f:/Excalibur/data.
Okay.
And what I'm trying to do with this is relativize the path so that it gets rid of the f:/Excalibur/data, but maintains the /Solomon/2013-105 kind of thing.
So those have to match, otherwise it won't work. Is that true? Is that Naveed? Can you hear me?
Yes.
Yeah. So you're getting f:/Excalibur data from the config, and you're going to the finished sample list, and it's just doing. It's sort of.
So what I need the f/Excalibur/data for from the config file is to strip that part off of the path.
I see.
Because when we send this over to Sequest or to AutoSearch, it won't know, or it actually needs to know what the rest of the path is, but it doesn't need to know the Excalibur/data part.
I see. So in AutoSearch, you land the data into, basically AutoSearch root /Salomon. So it's, I see.
Exactly.
So you're setting up the relative starting point on AutoSearch and AutoLoad. I see. Do you understand
Exactly.
that, Sid?
Yeah, I think that makes sense.
Okay. Cool.
So that's exactly what's happening right here with the relativize. So relativize is going to get rid of anything that the base directory, which I got from the param file, and the fully qualified file path is going to basically strip the Excalibur part out of it.
Got it.
Okay, got it.
Yeah, so then once we get the directory stream or the list of files for that sample, we iterate over it right here, and we send the file over. First, we send the file name, and it looks like a lot, but that's just because we have to get rid of all the rest, the path stuff at the beginning, and just get the file name over. So we send over the file name, and then we flush the output stream. Then we send over the file size, and so we have to flush every time we write. And then once we send over the file size, the reason we have to do that is because AutoSearch needs to know how big the file is going to be to allocate that much space.
So it makes like a little icon in the destination location that's before you actually send the data. Is that what's going on here?
Sorry, what was that?
So you're sending a file from auto update to auto search, and here you first pass the name and then the size. On auto search, when it receives the name and the size, does it make a little icon for the file in the destination directory on auto search?
It will as soon as it receives its first packet of data.
I see. So, okay. So it's just sort of how this protocol is set up.
Yeah, so once you have the name and the size, the Java program will know how much space to allocate, but it won't actually put any of that on your computer until it starts receiving data.
Now, does it go through RAM to disk or directly to disk?
I believe it goes from RAM to disk.
Okay, so you pass the whole file over in RAM to auto update, because wouldn't there be memory problems?
No, sorry, no. It goes. So the only parts that are in RAM are the small packets. So these 4 kilobyte packets that I'm sending over.
I see.
That's the only thing that gets stored in RAM.
I see.
And once it's in RAM, it immediately gets stored to disk.
Packet by packet,
you get a new 4 kilobyte packet.
I see. So packet by packet, basically 4 kilobyte to RAM, then to disk. 4 kilobyte to RAM, then to disk. Okay, got it.
So this while loop here is reading in from the file. So we get a new file info stream, and we read in from the file and then send that amount of data, which is at maximum 4,092 bytes. We send that over to auto search, which then reads it and stores it in the file on disk. So once that happens, we close the file we close the file reader, and we run it all over again for the next file, because we have to continue this for loop until all the files are gone.
So it basically just does all the files in a directory, no matter.
It does all the files in the directory that are specified for this sample.
I see. So like in the future, if I added new files, it would pick those up and move them as well.
Yes, as long as they still have the same sample name.
I see. So they have to be sample name and then
.star. It can be sample name .anything.
I see. So anything sample name .star, it moves over. Got it. Okay. Cool.
So that's actually sending all the data over. Some problems we can run into sometimes is when auto update doesn't have access to the data. So when the computer automatically locks the folders in, and we have to get authentication. So in the case of those types of errors, you should get a pop-up. But other than that, it should work.
So basically, is that Windows security permissions that would be defective?
Yeah. Sometimes Windows won't let you access it.
Okay.
And then you have to run the folder and then type in the password.
I see. But this is not Windows file sharing, right?
Oh, no, but also, actually, that was a bigger problem when we were trying to get the data from auto search, from EPSCoR LTQ.
Yeah.
But because this is running on EPSCoR, I think it should be fine.
But there is no permissions. Like, how are you setting this socket up? There's no passwords and stuff?
No.
So it's just basically, as long as you have the software, it'll communicate.
Yeah,
and
exactly.
authenticate. And the security settings, so basically the user that's logged in that's running auto update and auto search has to be the same user on the same domain user?
No, it does not, actually. It can be anybody on either of the two computers, as long as both users are running the two programs, because only these two programs can communicate with each other. If it's a different program on the same socket, it'll throw a bunch of errors.
Okay, that I understand, but I'm trying to understand the security issue. Is that a deprecated problem?
It might be, but every now and then you'll have to... So, when Java is trying to access the file, if Windows has it locked, it won't be able to read from it.
What does a user do when that happens besides receive a confusing error message? How does a user fix that?
That's when the user has to actually go to the location.
Okay.
And usually that requires getting a password.
When you say go to the location, what would a user specifically do to go to?
They would go to run, I believe, and then in run go to the folder they're looking for.
So you would go to a network share?
It depends on where the data is located.
Well, so this error is generated on auto search?
It's usually, the only time I ever saw this error was on auto search.
And it's basically auto search trying to access files on its own computer?
No, this is when this was an error when auto search was trying to access files on EPSCoR LTQ.
I see.
And sometimes EPSCoR would not give it access.
Okay. And then
so really, it's not necessary, or it shouldn't be, but I left it in there in the event that we need access.
So a user would go to, for example,
they would go to run, and then they type in the location of the data we're looking for. So in this case, it'd be like f:/Excalibur/data.
But I thought, so are we going to run on auto search?
No.
We're going to run on auto update.
Yeah, so on the computer where you get the error.
Okay, so the error is generated on the source computer.
Yes.
And the source computer can access its own directory.
Yes.
Now I got it. Okay. Thanks, sorry.
Okay. So once auto search, or once auto update pushes all the data to auto search, that's basically all it does. It then goes into the table for the sample list, sets it to running, and then on the visual interface on the GUI, you'll see it's a sample is running. But that's only if auto search sends back a ready response. If auto search is already busy running another sample, it'll send back busy, in which case auto update will close both input and output socket or connection, and then close the socket itself.
I see. So each ping of the server requires the opening and closing of sockets?
Yeah. This way there's no need for a sustained connection.
Okay. Okay, so busy means like auto search is basically running a sequence search.
Exactly.
I see. Got it.
Okay, so then it'll sleep and then try to open another connection.
Yeah.
Okay.
Yeah, exactly. So it'll sleep for a minute and then try again. And the last response we can get is received. So you get this response once auto search has received the sample and everything's okay.
Okay.
At the end of this whole loop of sending things to auto search, we close down this while loop, and then we check the sample list one last time to see if there are any new samples, and we go to sleep.
Okay.
So we went over push files. Update sample list is basically, if we scroll back up,
Uh-oh. You got a plug, I hope?
yeah, I'm all set. Okay. So if we scroll back up, we can get to update sample list right here. So we update it with done, and if we scroll back down, update sample list will basically receive a sample and the status. It then finds that sample in the finished sample list and puts the status on it, so either single hash for done, double hash for error, or nothing else.
Okay.
And then it rewrites it, and then it writes that to the finished sample list. So whenever check sample list. Oh yeah, open listener, that's basically on auto update. You'll see a bunch of buttons on the bottom, and one of them is open, finish sample list, so this handles that. If you scroll back up to here, so communicating with auto search can generate a bunch of errors, and in the event there are errors, we close all of the input and output socket, or input and outputs for the socket, set the labels to error, and then we update the finished sample list with error. And then also this part is commented out, but it should work when it's ready. Just all it needs to do is be uncommented. It counts the number of errors and then sends you a message whenever you've reached 20.
I see. Who does the mail go to? Is it a config?
It should go to you.
But where do you specify it?
Okay, so it specifies, so the way that works is, let's go to our accesses or mutators. Where did I set this up? Oh yeah, okay. So it gets the email address from the username that's specified in the file user2mail.txt, which is inside of the application folder.
Okay.
And then it has messages for when samples have been completed, when there's a sequest error to connect, and in this case, form.get username. So there should be a get username method here. Oh yeah, here we go. So it sends it to you.
Wait, so it's hard-coded only to send things to me, or?
It's hard-coded only on auto update to send it to you. For everybody else, it gets the actual user, the owner of the sample.
What do you mean for everybody else? I mean,
So say there's an error on auto search or on auto update,
yeah.
It won't send it to you, instead it'll send it to the owner of the sample.
When would it send it to me?
If you are the owner of the sample, or if there's an error on auto update only.
Error on auto update only. That's hard. So that's hard-coded. What email address?
It's whatever is in the application path.
What does that mean?
Otherwise, if it's sending the error to a user, then it gets that from the config file, right?
Yeah, so it actually gets the username from the
sample list, right?
So it gets the username from the finished sample list. So here it'd be like Nichin, but
okay, and then it uses the .text in the application root to associate usernames with email addresses, right?
Exactly.
And I see. And so the Artman is also using that .text, and these are sort of more global pipeline functionality messages, error messages.
Yeah.
I see.
Yeah, so mail isn't a module, so it's going to be used for the entire pipeline, not just for auto update.
And so only auto update is sending emails? Auto search doesn't do its own emails?
It does, or it will when functionality is built in, but it's basically whenever you want to send an email, all you have to do is call the method.
Okay.
Where did I put it? Yeah. So all you have to do is call a method new mail, and then this, which will send it the form params, and then the set of errors, or the set of parameters, so either error or success, and what the error is, kind of thing. So
each of these words are variables that hold a text string in the email message?
Exactly. So in mail, if we look, if we see that there's a success, it sends a success email.
Okay.
Or if there's an error, and then there's a connect, and then there's a sequest.
Yeah.
Or if there's an error, to connect to loader.
Yeah.
So.
Wow, so if auto search can't connect to auto load, then auto update sends an email message?
No, so in that case, I put this into auto search.
Yep.
And I put literally this exact same line, or these 3 lines, this if statement to here. I put that in the auto search, and just change this last one to error connects to loader, and then the mail application will know that it just can't connect to loader.
Okay.
Okay, so that was auto update. Is that good? Any questions on auto update, or are we all set?
Let's see. So the bug that we're currently having is, where is that generally isolated? Like the fact that we can't get the pipeline to work? Is that in auto load?
Yeah, I think that's auto load.
Okay, we'll get to that later.
Okay.
And there was a bug with, wasn't there a bug with inappropriate double hashing or single hashing?
Yeah, I fixed that, I believe.
And what was the bug that we were seeing before with that?
Yeah, so it would go ahead and double hash everything.
That's right.
If it couldn't connect to auto search, in the event that auto search was already busy.
Okay. All right. Cool.
But I hopefully fixed that.
So next is auto search.
Yes. Okay. So auto search again starts the same way by setting up the GUI. This is basically a window listener, so when you try to close the window, if there is a sample running, it warns you before you quit. It's usual stuff.
So what is all this other stuff?
So this is all just to set up the GUI.
I see.
So yeah, all of that was just necessary to get the visual interface.
Judson, do you know GUI stuff in Java?
Yeah, I know. It's all swing, right?
Yeah, it's all swing.
I'm pretty familiar.
Cool.
All the GUI should be set. You shouldn't need to change anything, but I have it pretty well commented if you just want to go through and look at it. So
cool.
So again, we have our accessors and mutators up top. We use them a lot more now. So get username. The username is set when we read in the file name, and as you saw, the file name holds the user it belongs to. And then is busy and set busy are used to tell auto update when auto search is busy. All right, so let's get into the meat of things. So load form, it just sets up the parameter file and everything, and then this is the big one. So it starts a server socket, and it listens for it. Basically, it allows the server socket to start listening for incoming requests from auto update. So if we look at auto update server socket, that's what AU server socket stands for. We go down, and we start listening. So while we're listening, any new connection we get from auto update, we accept that socket, and we start a new thread called AU client thread. So this is auto update client thread. And auto update client thread handles all the communication between auto search and a particular instance of auto update. So every single time auto update opens a new socket to connect to auto search, a new client thread is going to be created, and whenever the socket is closed upon completion or whenever it's received, or if there's an error or anything, the client will close along with the socket.
Okay, so this allows us to do multiple instruments coming into one auto search, right?
Exactly.
Okay.
So, all of this is set up and run. So we start reading the inputs. So as you can see, we have a read UTF here. That's because in auto update we did a write UTF. This way auto search, or excuse me, this AU client thread is always waiting for the appropriate data type to come over the wire.
I see.
So if it doesn't receive the appropriate data type, it won't continue.
So UTF is the character set?
Exactly. So the read UTF will be either ready or, yeah, so the first input is always a ready query.
So you always have to specify the character set when you have read or write.
Or not the character set, but the type, the primitive type in Java.
Okay.
So here it's UTF, which is the primitive type string.
What's a
But if you
primitive
come
type?
down here,
Help me to understand what that
Yeah. Why isn't it just read string?
it's the way Java has the strings being sent over sockets, they call them UTF.
Okay.
But right here, you can see in.readInt. So this is reading the primitive type integer. So if it doesn't receive an integer, it won't continue or it'll throw you an error.
Okay. Okay.
So after the ready query, if it's busy, it'll send busy. And if it's ready for a new sample, it will send back to auto update ready. And then auto update will send back the file name, which it reads in. It then resends the right here. This is the relative, getting the relative path that we talked about earlier with the config file and the fully qualified path.
I see. So it's appending the sequest-based folder onto the relative path. Got it.
So what auto update sent over right now was a relativized path, and this method right here is just setting it up so that we put it into the right sequest folder.
Okay.
Then we read in the number of files we're going to be reading, we're going to be receiving, and then we start actually receiving the files down here. So we have this for loop that iterates over the number of files we have to receive. We read in the file name in read UTF. We then delete anything that exists at that location already as that file name, so that way we don't have two copies floating around. And then we read in the file size, which is the read long. And here, this while loop is us reading in the file itself. So if you remember in auto update, we sent it in chunks of 4092 bytes.
Hold on. Your screen is not updating. I'm not seeing a while. Maybe a networking glitch now? I'm not seeing anything happening on your screen.
Yeah, mine is lagged too.
I switched back to the main Google Hangout screen. Did that update for you guys?
I'm not getting.
No, not for me.
You may maybe bounce out of share screen and back in.
Yeah. Okay.
Oh, it's dark now.
Yeah.
Okay.
Yeah?
Yeah, I'm seeing the Hangouts page. Oh, there it is. Okay. Yep, now I'm there. It's back. It's up to date.
Great. Justin, is it up to date for you?
Yeah, that's better.
Cool. So this while loop is the actual reading of the files. And if you remember in auto update, we sent files in chunks of 4092 bytes. So right now we're reading in chunks of 4092. So you read, and then you immediately write that buffer of 4092 bytes to the disk, which is what this is doing. And then this progress monitor is used basically for the large files, just to see how much of the large file has been sent, so you're not just waiting there and wondering if you're actually receiving the file. This gives you a visual response.
So that's a GUI element, a little subroutine for a progress bar.
Mm-hmm.
Okay.
So that's for receiving files. And then we receive the final thing we receive is the complete file name, which is in finish sample list. So what we receive basically the entire line from finish sample list, which has the sample name, the method, the username, and the sample QID.
Yeah.
So I have all that. That's the last thing we receive. Then we send back to auto update received. So auto update knows we received it, and then we do process sample. Process sample is where everything actually is. Just scroll down, process sample. This is the method that parses the string that's coming through auto update, and that string contains all the information like I just said: client ID, sample location, user, etc. And it also calls all the other methods for actually running the search, such as make DTAs and calling the actual search engine. So it is at this point in the program where we set auto search to busy. So from now on, any incoming queries will be responded with busy. This .pause, basically this is a helper method, so that if you click the pause button, it will print out sample processing, so you know where and for how long the program has been paused for. Alright, so let's start with parsing the incoming message. So sample is what we received, the last thing we received from auto update, which was the full sample
so that's
string
that's a
from finished sample list.
Okay, so that's a finished sample list, a whole complete unedited string.
Exactly.
Okay.
So we split everything by pluses, which is how everything's demarcated in the finished sample list. If there's a plus, it's a new parameter. So that's exactly what we're doing. The first thing we get is the client ID. So where we got it from. In this case, in this example, it's core. So that's the first thing we get. The second thing we get is the sample path. So in this case, it's f:/Excalibur/data ...
That's the full path. Full path.
Yeah, the full path. Okay. Then we have to do some manipulation to get rid of the f::Excalibur part, and just end up with the sample, the actual sample, which in this case it would be something like rep1_0min_experiment1 kind of thing.
So when you switch to text editor, there's about a 10-second lag until we see something. So, okay, so show us again. We now see it. So could you repeat?
So, can you guys see what I highlighted?
I see it.
Yeah.
Perfect. So that's the actual sample name.
Yep.
So that's basically this little bit of string manipulation is just to get the sample name and the file extension. And then we log that we got the sample, and this is what we're processing now. So that shows up in the GUI. Okay. Now we do a little bit more relativizing paths to get the proper path that we're looking for, which we're going to call sample path. So sample path is, or sample local path, excuse me, is pretty much the path we're always going to be using at this point. It is a fully qualified path on Sequest that ends with the sample name, but no extension.
Okay, got it.
So this way we can either say sample local path .txt, and that'll create a file at the sample local path with the extension .txt, or we can use this to create a folder at that location.
Makes sense.
Then we set up backup paths, which we get from the parameters. And then we continue parsing the string that we just got from auto update. So instrument type, the parameter, the search param, the search engine, the username, the sample QID, the MS method, all that stuff. It's demarcated in the sample local path, or in the finished sample list. So this basically we're just getting everything out of there. This to_write is a new vector, and we're basically adding all these because we have to write a new we write a text file that has all these all this information on it. So the file name, the raw path, the backup path for the zip, the username, and all that stuff. It's all set. It's all written in the setup file.
I see. So that's that temporary text file that sort of has all the information in it.
Exactly.
Okay.
So then we write that with all the information we just got.
Okay.
And then sometimes, this was in the Visual Basic and our old version of Java. I don't know if we still need it, but sometimes if sometimes the finished sample list, the string you get will be of different lengths. It either has a sample QID at part 7, or it has the folder, the experiment folder, the store location, and everything else at part 7, 8, 9. Okay. So we have to basically have both of those possible outcomes ready to go.
So maybe you're going to get to this, but so everything from the to_write vector is then written to a file, but you said it's temporary. So what is that file?
It's not temporary. It's never used, but it is sent over to auto update as a text file. And it's sent over to auto load, and auto load then uses this text file.
Okay, for what? Just to display like the status information?
So it uses this to basically write a different text file, to be honest, is what it does. But it needs all this information from auto search.
Okay.
And this is the best way to send it over. Is that okay? You didn't sound very excited about that.
Yeah, well, so in autoload, isn't that text file used to sort of drive the automation of analysis?
Yeah, it's used, so this text file is used a lot in autoload to basically get all these setup things out of here and put it into autoload.
So there's probably more than one way to do this. This is an older way that's carried over, right, from VB.
Yeah, but at the same time, a different way that we could do this would be sending it over as a, like over the socket connection.
Exactly.
But this, I think, is actually an easier way to do it.
Okay.
So.
Right. Okay.
Okay, so this is, so this is process sample. So once we have all these things done and ready to go, once we've read in and parsed the entire string, we then start doing all of the actual search stuff. So we now start calling the methods, these sub-methods that run the actual program. So now we do a search. So search starts with make DTAs. So let's go down to make DTAs, which is right here. We now use MS convert. Before we used extract MSN, we don't do that anymore. So here's MS convert. So what we do is you create a command string, and that is actually unnecessary, but it's good for printing out what the command is. But this builder is the more important part. This builder is what actually creates the process that will make the DTAs.
So in this section, there's no user feedback. It basically unnecessarily hides useful progress information, right?
So I tried. So what should happen is there should be a pop-up for a pop-up command prompt. But I think the new version of Java doesn't do that anymore. I think it automatically hides it.
Okay, well, so that's something to look at. So, because it just sort of does it without showing you what comes, the responses from, what is it, not extraction, whatever you're using.
Sorry, what was that? I can't hear you.
So this is using, so you don't get the, what's the name of the program that makes DTAs currently?
That makes DTAs?
Yes.
Sorry, MS Convert.
So MS Convert provides some messages as it's processing a file, and those messages don't show up currently. Like, you know, it says I'm
so
and things like
I have that set up so that it actually reads, so Java should read in the file, read in any output coming from MS Convert or any of the other programs we use. But unfortunately, I don't think it's working properly, and I've searched and I don't really know why.
Okay.
But I think it's the new way Java's doing it. It just doesn't like having that pop-up there, and so I had to redirect the input, the standard in and standard output from these processes. So I redirected the output, but I still can't get it to show up in the command prompt. So
Okay, so we have sequest MGF maker, and then extract MSMS. So once you make a MZXML file here, and then you
Yeah, so this is us trying to. Yeah, this is an MGF maker. This
an MGF, and then the MGF is blown out to DTAs.
exactly. So it's the opposite way we used to do it.
Right.
Yeah, so this makes MGF.
I'm not actually sure what an MGF is.
So DTA file is one DTA file per MSMS spectra, and it's just a peak list. And a MGF file is a concatenation of all DTA files into a single text file. And so MGF is a text file that has basically all the DTAs just basically carriage returned onto each other. And so the particular version of the software that converts the instrument raw binary file to text format only has the capability to make MGF and not to make DTAs. But our pipeline sort of works on the idea that we can have access to DTAs. So we take that MGF and we basically blow it out into separate DTA files with this little Java program, which is, where is that? Extract msms.jar. That just blows out the DTAs, I think.
Okay, right.
Exactly. So we build that process. We supposedly read in any standard input and standard output. We wait for the thread to finish for thread synchrony. And then we split the MGF files into the DTAs using the Perl script. So we have this program which is in the app folder.
Hold on, go back. So I was wrong. That was not where we made the DTAs. Go back, scroll up, please. I'm not getting any screen updates. Are you scrolling?
So this stuff.
I'm not getting any screen updates.
Yeah, it's lagging.
Alright.
Yeah, so the stuff up there is not making the DTAs. The .jar. Because that's done in a Perl script. Okay, we're good.
Okay.
Yeah.
So what I've highlighted here doesn't actually make the DTAs. This is just in the event we're not working with a raw file, if we're working with a different type of file.
I see.
So we actually make the DTAs here.
Okay, got it. Yeah, you even do command/C and it doesn't work, huh?
Yeah, so
weird.
It just doesn't like it, but this is us splitting the MGF into DTAs using the Perl script.
Yeah.
So the process builder used to be different, but now it requires you to split every single command using commas. So CMD is one command, /C is another, Perl, and then so we got to split everything up into its own little section.
So basically, anywhere there's a space in the command, you need to put a comma.
Exactly.
That's great.
And it doesn't like quotes either. So you shouldn't have any quotes. What you should do, if you have like a path that has spaces in it and you want to escape it with quotes, you gotta first put that path into a string and then type that string in there.
Wow. Yeah.
Yep. So anyway, we do the same thing. We build the process. We supposedly read in any input. And then we wait for thread synchrony. And then once we have the DTAs, we create the MZXML. It's basically the exact same format we just had. We create a builder. MGF maker creates the MZXML, which is specified right here. We have the filter.
So the MGF, just for Judson, the MGF maker is this, what's the name of it? It escaped me again.
Extract MS, no, it's MS Convert.
MS Convert can both make an MGF and it can make sort of an XML formatted data file. And that XML formatted file is used, I think, by, what's his name? Hackney's. It's how we get the raw data into SQL. I don't know if you're still doing that.
Actually, I think Dan Hackney's stuff gets sent right before the auto load stuff. I think it just somehow just scrapes the data and stuffs it in the into the SQL database.
Yeah, but I think it's from XML.
Okay.
So that's why we need this file.
Yeah, so we have the MZXML. It's done in the same way. We attempt to print out any standard out and any error out. Yeah. So then we wait to maintain that synchrony. And that is the entire make DTAs method. So then, once we make the DTAs, we come back up here into our search method. And the search, we usually only do mascot searches, so we're going to scroll down and find mascot search. Here we are. Again, we have the this.pause here, so we know when and where we're paused, if we ever do decide to pause. And the first thing we do is we delete the output file from mascot, because we use the output file to determine whether or not mascot has finished running.
So this is the Boolean 1 or 0?
No, this is not the Boolean. This is the location of the XML file that we download from Mascot Web.
Okay, got it.
Yeah, so that file path is just stored in this file.
You just delete the file.
Yeah. This is the deprecated MGF making business that we no longer use. Okay, so we got to create the folder in mascot. The folder in mascot is a very specified date format, or a folder format where we have the date, and then we have the sample name. So that's basically what this is doing. We have a new date format where we have the year, month, day, hour, minute, and second. We add, so we put the sample first and then the date format, the new date, and then .mgf.
So this is moving the file to a different This is moving it to the watch folder?
Exactly. So that's what we do here. So files.move. We move the file from where it is. Right now it's stored in merge.mgf. And we put it into the new folder, which is MGF folder, which we specify by getting the mascot daemon folder, which is the watch folder, and then the...
But this comes from finished sample list, no? The .par in the finished sample list allows you to specify which folder this is going to go in? Because it's not static, it depends on each sample.
Yeah, exactly. So we... So what we do is we get the base folder for where mascot's completely watching, and then we get the search param.
Got it. Yeah.
Which is what we got when we parsed in the finished sample list string. And then we add MGF, which is the sample plus the new date format.
Yep.
So we move that. So we move the merge.mgf into that location.
Yeah.
Once it's in that location, mascot should automatically detect it and run.
Yeah.
So now what we do is we wait. The way, as I mentioned earlier, that we know mascot has finished running is when the result file, mascot downloader output, is back in our folder.
Yeah,
so we deleted it, it was gone.
Let me explain to Judson what happened. So in the mascot we use something called the mascot daemon to set up these watch folders, and it associates a search parameter file with a folder location. So the input data goes into the folder location, and mascot is pinging this thing. A mascot search is initiated, it completes, and in the mascot daemon we specify post execution tasks, and basically that launches, I think it's a Java program that you basically mascot passes the unique ID of the sample to this downloader Java program, and it uses wget web downloading to actually download the output file, and then you take over at that point. So it downloads .xml, right? It makes
it downloads the XML.
Yeah.
And that's when we take over again. So that's what we're doing here. We're waiting for that file to exist. If it doesn't exist, we go to sleep for 60 seconds, and when it finally does exist, what does this do? It looks like we move the MGF file back into our sample local path.
Yep.
And so we know mascot is finished. We then have the result XML and the CSV, which is also a new download that we get.
Yep.
And we read in all the so we read in the lines for the result file. The result file begins with OK and then a path name, and that path basically points us to the XML and the CSV file. So now we have both of those stored as variables. We move them, they get downloaded into the app folder. We move them into our sample folder so we can send them over to autoload when they're needed.
Yeah. Okay.
So once we have the XML file, we start making the out files with this Java program. So tab XML2 out.jar basically makes all of the out files that we need.
Yeah, so Judson, just to fill you in, there's Sequest searches use DTAs as input and outs as output. Mascot has sort of this PEP XML output, but all of our infrastructure originally was designed for Sequest. So we convert the mascot style output to a Sequest output so we don't have to redesign all the other stuff that we've done. So out file is basically for each input MSMS spectra, the out file is the top 10 possible peptide sequence matches for the MSMS file, along with associated like X-core, basically how good of a match scores are in there. And so this out file and the DTA file are going to be on the autoload program, are going to be uploaded into FileMaker. So
Okay.
it's sort of a historic reason why we're doing some of this.
Okay, got it.
Okay, go ahead, Naveed, sorry.
Yeah, so we're running it basically the same way we run all the other programs, the external programs. We make the XML, we make the out file from the XML, we read it and you send it out and try to print it, but it doesn't work. And then we wait for that process to end. And that's it. That is all of the search.
Right. So now you got.
So if you scroll back up, so that was all of mascot search. we called mascot search from the search method after we made the DTAs, and we called the search method from our process sample method. So next, we have zip files. Zip files basically zips all the files in that folder to send the loader, and then we send the loader. So let's go look at both of those real quick.
Yeah, and Judson, so since we're making one DTA for every MSMS file, typically the mass spec generates about 20,000 MSMS files, but only a subset of those are actually generated when we make the DTAs. Based on, it has to have a minimum number of peaks or something like that. But we're literally talking about potentially thousands of DTAs and thousands of corresponding out files. So, we used to transfer files using Windows file sharing and having thousands, and when you have lots of experiments, you'll end up with millions of unique files. Windows just falls apart. So we zip everything up before we push things over the network. So that's why we need to zip.
Okay.
Yep.
Cool. So we zip the files up. This basically runs the it iterates through the folder, zips everything up, packages it up all nicely, and creates a zip file. Java has its own way of doing zip, which is zip entries and zip output streams. So basically, we just write the same way we wrote before, except we use a zip output stream instead of a file output stream. Then we get all files with just a helper method that I created to make it easier to get all the files in a certain directory. But then we have send to loader, which we copy the zip file to auto load using Java's built-in copy function. So we copy the zip file from the sample local path to the loader root path.
So this isn't using sockets, Naveed?
This is not using sockets, no.
Is there a reason to do copy, or it just hasn't been updated?
It's actually easier to do it this way. The only reason we did it over sockets last time was because the hospital wasn't letting you connect with the copy method.
But this is using Windows file sharing when you use the copy method?
Yes, I believe so.
Okay. So it's something to be aware of. So we're going to have the problem of you have to store you have to cache the file, the Windows file sharing password. Like every time you restart the computer, you have to, because Windows is stupid, even if you store the password, you have to re-enter it. So, okay, so this is, Judson, this might be an area where you want to bring this up to sockets.
Gotcha.
Okay.
If you want to use sockets, you can use you can use it the same way I used it to get files from auto update to auto search. Over the same mechanism.
Okay.
So once we have everything copied over to auto load, we open up a new socket. We tell loader, we send to loader the sample name. Once loader has the sample name, it will go ahead and write it to the finished sample list itself.
Right.
So we don't do that, we just send it over to the sample name.
And then you make a
and then we send it to Proteome.
Backup on
Yeah, we send the backup to Proteome.
And is this using sockets, or this is copy again?
Yeah, this is Windows file share again.
Okay. But this one has to be Windows file sharing because there's no client on Proteome.
Yeah.
So we don't have a choice with this one. Whereas Loader has a Java program. So Okay.
Okay. So once that's done, once we backed it up and we sent it to loader, and we just start deleting all the files. So we just delete all the files from auto search, so they're no longer taking space because they're already backed up elsewhere.
All right.
Then here are some helper methods. So pause. We pause this method. We pause the thread, and we print out auto search has been paused at for X number, or at the method, which is the parameter we kept sending in, for X number of minutes.
Right.
This is the priority button listener. This is where you can set priority of the clients. It doesn't really do much at this point because we haven't set up a protocol for different priority clients, but all the groundwork is laid out for that to work.
So, Judson, so this is if you have multiple mass specs all hitting one auto search. Sometimes you're doing really high priority work on one of those mass specs, and you want those to cut in line in front of other instruments, and this is a way for end users to sort of manage how quickly their data is analyzed. So what needs to be done? What needs to be done with this, Naveed, to make it work?
What needs to be done is basically when you have multiple connections coming in, you need to prioritize the one with the lower priority number, and that's not being done currently. But we are receiving the priority of the client.
I see. So when you
basically all that needs to be,
when you make the decision to jump into a sample, you have to add some logic to say, you know, are there any higher priority jobs waiting?
Exactly. Exactly. Great. Yeah, so that is pretty much all auto search.
Okay.
Any questions?
No, I think that's good. The main thing that Judson potentially would be working on is just ironing out the kinks in auto load.
Exactly. Yeah. So let's.
These two seem to be.
Let's hit up auto load.
Pretty well, Judson.
Okay.
So this is auto load. Again, we start with the GUI basics. We set everything up, just like last time. All right, great. Access and accessors and mutators.
Wait, hold on.
The is busy.
You're lagging. Hold on.
All right, let's try this again.
Actually, can you go on for 15 seconds? I just have to run and get my charger.
Yeah.
My laptop. Okay, I'll be right back.
Okay. This is like a marathon. Oh my god, I hope it's still capturing. Should be. 79.9. I'm using on the Mac, there's this program called SnapZ, which does video capture with sound, and you can make it in a compressed format, and it's basically anything on the screen. It's pretty handy.
Nice. So I know QuickTime 10 can actually do that too.
Is it? Oh,
the screen recordings with sound.
So,
it does, but I don't know if it does it in a compressed format. So.
Well, it actually. So it doesn't compress on the fly. It post-compress. So after this is done, it's going to just chew on it all night. But so the QuickTime 10 thing, basically you can use QuickTime to capture the screen without the QuickTime player present?
Yeah, exactly.
Do you need
so if you open up QuickTime,
okay, well,
you'll be able to do it.
Okay.
Yeah. We'll do that some other time.
All right, I think.
All right, yeah, I'm back.
Great. We'll start screen sharing. Cool. Alright, so this is auto load. Basic, started out with GUI, normal stuff. Some things to take into account right now. We find the number of cores available, so we can do some really cool stuff with that later. And the is busy now isn't just a Boolean with true or false. We also have to take into account the external file that has either a 1 or a 0. So if it's 0, then it is not busy. If it's 1, then it is busy. Standard stuff.
Which file is this? So this is, what's the path?
This is loaddone.txt.
And what files?
So this is
Go ahead.
This is what FileMaker will update when it's doing a load.
I see. I see. So this is the way to communicate with FileMaker.
Yeah. So for the most part, we'll be using the booleans is busy or is not busy.
Okay.
But we will have to read in from that file. And at the same time, we set busy using the same protocol. So if the system is busy, then we write a 1, and if it's not busy, we write a 0.
So you start from the very get-go working with this Boolean file.
Yeah, I mean it's something that has to be built in. So.
Okay.
Great. Everything else is pretty similar in terms of accessors and mutators. And here we got methods.
Hold on. Judson, do you know what an accessor and a mutator is? Is this a Java thing?
Yes.
Okay. All right.
Yes.
That's all that matters. Continue.
I had about a semester of Java, so I got that far.
Okay.
Great. Okay. So you have load form again, which sets up the entire root program. We have the new parameters and everything. Then we run this. This is basically everything that's running. So we check the sample list. If samples to run, which is what we get in from check sample list. If it's greater than 0, we pull the sample and we start running it. Else, we put the thread to sleep and we wait. So let's first check out auto search server socket. So auto search server socket is a thread which is always listening. It's basically doing the same thing that the auto update server socket was doing on auto search, where it's just listening for any incoming connections, and it starts a new auto search client thread whenever it gets a new connection. So let's look at that. So when auto search sent over the file name to auto update, this is where we handle all of that.
So it did that over sockets and the file transfer over Windows file sharing.
Exactly. So it basically just sends in the file name here, which is input. That's the new sample. It's called input. We then add the sample, which we'll go over that method momentarily, and then we send that to the main form. So the actual auto load knows that we have something in here. So add sample basically takes the sample that we just received and writes it to the end of finished sample list.
Okay. And so, Judson, it's a little confusing. Finished sample list has a different format on this computer. It doesn't have all the plus signs. It's just the name of the file without the dot extension. So
Got it.
Just straight up file name.
Okay.
Okay, continue.
So we write it to the finished sample list, and then we go back to our main form, and we check the fitness sample list. So let's go look at that method real quick. So it's in a section called sample list methods. And we just basically check this fitness sample list. We read the lines, we find anything that aren't doubly hashed, or sorry, we don't find anything that's singly hashed. And anything that's not hashed gets added to the sample list first, and then anything that's doubly hashed gets added to the sample list second, so it runs all the new samples first, and then all the error samples second. So let's go back up. So load sample. Load sample has the same function that process sample had in auto search. This just calls all the methods needed to actually load the sample. So first we start with unzip. We go down to unzip. We unzip the file using Java's built-in zip. So we no longer have to use WinZip or 7-zip or any of that nonsense, external programs. We just use Java's built-in zip. So we unzip using zip entries like we did last time, and input-output streams. Except now, because we're writing from a zip file to a normal file, we have we use a normal file output stream to write to it instead of a zip output stream.
Okay.
Yeah.
And we were getting problems of doubling up files. Do you do a delete here? Like you clear out?
So the first thing I do actually, if you can scroll back up to load sample, is
just wipe.
I delete. Actually, I looks like I commented that out. Why did I comment that out? Let's see. Oh, I commented this out because this is what was giving us issues in terms of the file system locking itself and not wanting to give any other programs access to it. So instead of deleting from the beginning, I delete everything at the very end. Yeah.
Okay, so, but if we have an aborted run, then we're going to pile up, right? Like, say,
What was that?
Say, like, extract out crashes. Your whole program comes down and we restart your program. We'll still have lagging files. If we don't get to the end of all of these steps, it won't delete the files.
Mm-hmm.
And then we'll potentially aggregate, right?
Let's see, I could also do... That should take care of that.
Okay.
Yeah, just delete at the beginning and the end.
Okay, cool. So delete files works and delete temp files has some problem in it.
Yeah, so delete files instead is a method that doesn't use Java 7 file system, but uses the old Java file system to delete. So
that's good. Okay, cool.
Yeah. So after we unzip everything, we read and make the setup file. So this is a pretty long method. What it does is it reads in that text file we made in auto search
Yeah.
that you guys were asking about. We read that in. We get all the information from there, like raw path, the backup path, username, the MS method, all that good stuff. And then we have to write that to a new sample, a new setup file called load parameter setup. So we write all that to the new load parameter setup file. But then we also have to do, where did I put it? Here we go. Okay. So get raw info. So this is the part where we open up the raw file itself, and Java begins to take control of the computer and send a bunch of send keys.
Oh yeah, so this is basically it's getting the MS method. It's getting some metadata out of there by copying and pasting.
Yeah. So if we go down to that method, get raw info. So I have all these exceptions being thrown. I should probably explain that. Let's go back up here. So the way I'm running this program is that if there's any exception at all, meaning the program broke down, we skip the sample, so there's no lag. Because loading takes the longest time, and if there's an error, we don't want it to just keep looping and trying.
Okay.
So what we do is we skip the sample and it comes back to it later.
Okay.
So let's go back down to...
So you pound it.
Alright, so if we go back to the get raw info, this is the method that opens up the raw file and sends a bunch of send keys to get the data.
Does Judson
So first thing we do...
Well, hold on. Does Judson know what a send key is?
No, I don't.
Okay, explain that.
So a send key is basically where the Java program will take over the computer and it will send inputs as if someone was actually typing on the computer. So the problem with this is no one else can actually be touching the computer, or else the send keys won't work. Everything will just get jumbled up and the program won't know what happened.
Okay.
These are basically virtual typings of the keyboard.
So basically, the raw file is proprietary, and in order for you to get access to some of the things, you have to literally go through the user interface, the Excalibur program that's provided by the instrument manufacturer. It's the only way to get access. We use it a lot in automation of data collection, where we're sending things. There's no API.
Okay.
It's a hack.
So anyway, we have to send these virtual keystrokes to copy and paste. So the first thing I do is I set the color of auto load to red. So if someone just happens to be on load at the time, they see it turning red, they'll immediately stop using it. I pause the thread for 30 seconds so whoever's using it has time to react and get off the computer and set everything else it was.
Does it give focus if it's not in focus?
It does not get focus because giving itself focus is actually a really hard thing to do.
Oh, really?
Because it's not, it doesn't use Windows file, it doesn't use Windows windowing system. It uses, because Java is running on a virtual machine, it uses the virtual machine windowing system.
Yeah.
So it's actually really difficult to make something on Windows get the focus, but that's exactly what we try to do here. So there's a library called windef.hwindow that attempts to bridge Java and Windows windowing system. So we first try to find the qual browser, which is what the raw file Excalibur thing is called. And once we find it, if we can't find it within 20 cycles, we break.
Well, hold on. So first you, in effect, double-click the raw file, which automatically opens qual browser when you do that.
Mm-hmm.
And then,
yeah, so that's right here.
Yeah. So you basically double-click the raw file, and a window that says Thermo Excalibur Qual Browser will pop up, and so now this thing is giving that focus.
Yes, exactly. So this is us trying to get focus on the qual browser. If we can't get it, we throw a new exception, and once that exception is thrown, the sample is trashed, or not trashed, but it's cycled to the end of the queue. And then, once we find it, we then start using the set keys. So this is when we do the virtual keystrokes.
Yeah, you're going to have to log that, like the reason, because sometimes what happens is like qual browser is already open. It actually is pretty common for the qual browser to get screwed up, and the VB program just sort of continued on, which is also not good. But there's got to be like some user feedback in the window. Basically, I couldn't give qual browser focus.
Yeah. So this the auto load exception.
Yeah.
It's an exception that I made myself. Okay. So if you scroll back up to where we catch it.
Does it put in the log or somewhere exactly the text, you know?
Exactly. So when we catch, what did I do with auto? Oh, let's see. Yeah. So the actual auto exception has the data there, which is printed out.
Okay.
Yeah, so it will print out qual browser window cannot be found.
Okay, cool.
Okay, so you will see that. Then we have the robot to start pressing the keys. So basically we're just doing the control copy and control paste kind of things. So this is MS Tune is basically what we copied here, which is in the clipboard now. So we set it to that. So we can get the second parameter, which is the MS method. So then we have the MS method. We put that into a different string, and then we quit. When we quit, we wait for the program to close completely, and then we copy out the MS tune, which we just copied, and the MS method, which we also just copied.
I see. So these end up in a file.
Okay, so this returns an array that has the rest of the things we need to add to the setup file that we were creating earlier. If you remember, that's where we left off.
Yeah.
So we called get raw info from the read and make setup file method. So if you scroll back down to where it was, here's get raw info. So we read the return that raw info sent, and we add it to the file that we're supposed to be writing. Then we add some more things to the file. And then we finally get a chance to write the setup file. Great.
Okay, so this.
Then the problem is file.
Hold on. So this is basically you aggregate all of this information in one file to facilitate import into FileMaker.
Okay.
Is that true? because you want to get this.
So all this data is used for FileMaker import. Problem is, FileMaker likes Mac returns at the end of lines, and this gave us back a bunch of window returns, Microsoft returns. So this little Perl script will change all of that. So Art, I know we used to have this program, line break win to Mac, but that wasn't working properly for some reason, so I just made this little Perl script to do it for us.
So it's just grabbing the character. Alright. Cool.
Alright, so that was read and make setup file. So if you look at what's next on our list, it is extract the out files and filter them. So all of the out files we made in auto search were sent over with the zip folder, and now we have to extract them and do a bunch of filtering. So usually our search engine is M for mascot. So we run this Java program, out file selector, which uses all these parameters and runs on our folder with all the out files in them.
So, Judson, this is basically the amount of DTA and out files is excessive, and we don't want to bloat the database, FileMaker database, with peptide spectrum matches that have no chance in hell of being correct. So we set in the config file the lowest peptide spectrum match score that's permitted, and this is just set based on experience that nothing is correct below these thresholds.
I see.
So that's why we do this. Otherwise, you would just bloat the database too much.
That comes from the paran file, the cutoff, you said?
Yeah, the paran.
Yes.
It's basically the config.config file. It's called a mouse score threshold.
Okay.
And I think there might be a mass error threshold too.
Yeah, so there are a bunch of thresholds that we use. Yeah, so there's a mass error that we get. There's a mouse score that we get.
Yeah.
So.
Okay, got it.
Alright, cool. So we do that in an attempt to actually be able to read the errors we're getting. I have redirected the output to a file. That did seem to work. So in the event you want to see what happened, you can just look at these files.
Okay, cool.
Okay, so that was extract out. Next on our list is logistic models, setup logistic model. So this is really simple. This is basically us just setting a file to be the default file we use for the RData model. So either we set it to, let's see. Yeah, so either we set, so let me start over. In the folder, in the directory c.temp/ or c/temp/ logistics score, there are 3 types of reduced.rdata that are there. There's just a reduced.rdata, then there's a reduced.rdata.sequest, and then there's a reduced.rdata.mascot. And the one we want to use is the one that only says reduced.rdata without the model. So what this is doing is it's basically setting the appropriate model to reduced.rdata. So if we use sequest, reduce.rdata.sequest is going to be renamed to just reduce.rdata, and it's going to be the same for the mascot. That's basically all we're doing right now.
So, Judson, let me fill you in. So basically, this is a mascot or sequest rescoring algorithm. We wrote that one paper on this, and it basically increases the yield of confident peptide assignments by rescoring. So the output of mascot is mouse score, and we basically provide our own unique score. It's called the logistics score. It's in the database under logistics score. And so these are we train the model based on manually validated data, and we have sort of different training sets for either mascot or sequest. So this is just basically selecting the appropriate trained model. Okay, continue.
Okay, so that was set up logistic model, a really short, simple method. Here we got FOSQuant. This is a big one. So this is all the FOS localization.
So this is basically a score. It gives you a probability that the position of the phosphorylation site is correct.
Okay. So, first things first, we test to see if there's any DTAs around. If there aren't any DTAs, we know that our thresholding didn't really work. But we usually do get a number of DTAs that's higher than 0, so we run FOSLocalization.bat, which opens a new command, or hopefully it does. And that command does a lot of FOS localization stuff. We send it the raw file and the config file, the CFG file.
So config file is the reformatted file that you got from auto search.
And then, so this quant, where did we write quant? So quant is basically whether it's a Boolean button. It's whether or not it's on or off. If it's on, we do one thing. If it's off, we do another. So if it's on, we start doing all this.
So this is
and this is where the multiple cores come in handy.
So yeah, this is there's a button on the user interface, quantitation on or off. So it's actually user specified. Like sometimes we want to analyze the data faster, so we skip quantitation. We just want to get like the yield of confident hits and nothing else. But in most cases, we're going to have quant on. I think the default should be on, right?
Yeah, the default is on.
Yeah. Okay, continue. Sorry.
So, this is where the cores come in handy. So we split the directories into the number of cores we have, or actually n-1 number of cores, and then we take a bunch of these out files that we got, and we split them up into these separate directories. So by splitting them up into these separate directories, we can do these peak calculations on each directory separately, and that will allow us to utilize all the cores we have.
So you open a separate process for each directory, and you get a core when you open a process in Windows.
So here's where we do the peak calculate. Yeah, so now we do the peak calculations. So
wait a minute, Naveed, you've switched from phosphorylation site localization to quantitation. So the phos localization is just That's not parallelized, right?
No, that is not.
So that just
So we do the false localization up here,
Yep.
and then we start parallelizing after that.
So this is getting ready for quantitation. Okay,
Yeah.
got it.
So now we do all the quantitation stuff. Let me see if I can find where we actually do the for loop. Okay, here we go. So here we do the Silac quantitation. This is just P calculation. So we open up a P calculator, which is another external program that we use. Send it the raw file, and that will give us all the P calculations. We wait for that process to end. Then we process the HTAPP XML quant using a Java program. These are basically mutually exclusive. If there's a raw file, we do the P calculation. If there isn't a raw file, we do this Java quantitation.
What's the case in which there wouldn't be a raw file?
That means we're not using a Thermo Finnegan mass spectrometer. It's actually totally untested. But that's basically, this provides an expansion of this software to be able to be run on any mass spectrometer, not just ones manufactured by Thermo.
Okay.
So all mass spectrometers have the capability to convert their proprietary binary format into the PEPX standardized format.
So once we have that process, this is the false localization process. Once that is done, which is what we're waiting for here, once that's done, we start doing the Silac quantitation. This is where we use our multiple cores. So we first figure out whether we're using iTrack, or if Silac equals 2, then that's iTrack, else we're using just normal Silac. And if we're using Silac, which is what we mostly do, we split it up into the number of cores. And so you can see we build this command using aqsilac.exe, and we build the same number of processes that we have cores. That way we can parallelize and use all the cores we have, be super quick about it. So that is us parallelizing quantitation. Okay. So that was the end of that method. So we scroll back up. Next is load to FileMaker. We're nearing the end here. Alright, load to FileMaker. This is another really big one. First thing we do is we do a start app bat, which will basically open up FileMaker and everything else associated with it. We then, once again, try to find the FileMaker instance. And now we're going to do some send keys again. So sending control 3 will start the loading script that we had set up. And that will basically take in everything that's in those temporary files, including that setup that we made a while back, and it will start the load. And that's pretty much automatic. That everything else is contained within FileMaker. And that's pretty much the end of it. Then we just have delete files, where we go ahead and delete all the files, and yeah.
So where were we? What's the bug that we're having now? It's basically it never analyzes.
Wait, I can't hear you.
It's what's the bug?
Yeah, you're really quiet, right?
What's the bug we're having now?
The bug we were having was that the file system would continuously lock itself down. And I'm pretty sure I pinpointed that to us using the new version of the Java file system, and Windows was not having it. It just didn't like it at all. And so when I switched back to the older version, I believe I got it to work. But I don't think I ever got a chance to do a full load on it.
So it's never been tested. Have we ever done any full loads?
I think I had a couple set up in the pipeline, but I was getting some other bugs instead.
Okay.
But if we run these again, I can try running these again this weekend remotely.
Okay.
And seeing what bugs I get, and then conveying that to Judson, and seeing if we can actually pinpoint the reason for those bugs and fix them.
So where were you running? Because I had to redo LTFT2. I don't know if you're running on that. I forget where you
I was using LTFT2 as the auto update source.
So
But really, these can be tested from anywhere. I was just using LTFT2 because it was an easy way to get things set up, and it wasn't going to mess with the existing pipeline.
well, maybe at this point it would be good for Judson to take over. I can sort of point him in the right direction. I think it's basically all done. It just we haven't been able to successfully test the full load. And then maybe Judson, as you get errors, you can work on it yourself, and you can't figure it out, just sort of ask Naveed for help directly.
Yeah, that makes sense. I don't have any questions for you right now, but I'm sure once I dig in, and I've actually had a chance to test this myself, there are a lot of things that are going to come out.
Right. I think that's the way to go, because, I mean, you need to move on to feed and do your project, in wherever you are in Boston. So, and that'll give, just you being available to answer Judson's questions will be totally invaluable.
Yeah, no, totally. You can always email me or call me or anything.
Cool. Yeah, so it sounds like the only major bug that you, at least that you know of right now, has to do with the old versus the new Java file system. And then, if there's any other, you mentioned a couple things, like just performance tweaks that might need to be made along the way. Is there anything else by way of just, things that need to be touched up or improvements that need to be made?
I don't think so.
Yeah, I would say the one long-term goal that we had discussed was, so the VB version of the program had ridiculously verbose logging to a text file of every single thing the program was doing. And right now we have bare minimum logging. And that log is really helpful. Like anytime you launch an external program, it would actually write to the log file the command line to launch the program. So you could actually just copy that into a Windows command and, offline to try and reproduce the error. It's just really useful. That would be one.
So I have a bunch of that stuff. Instead of being the log, I have it printing to standard out.
Yeah.
So if you want, what might be really helpful for debugging is launching this stuff from the command line instead of launching it as a jar file.
Yeah, but we want.
And if you launch it from the command line,
right.
it should be much easier for you to debug.
But I want that. I mean, all that stuff has to be like if I close the program, I can't have it be erased.
Yeah.
Ever. So it's got to go to a log file instead of just.
What was that? You want it all in a log file?
Yeah, it has to, because if you close the program, you lose all the critically useful information.
Yeah.
So that's something. That's a feature request I would categorize it.
Okay.
But the critical thing is just to get it working, because right now we're totally not using any of this software because the very last step doesn't load. So we're using Visual Basic. Everything you've seen is not being used until it all works. Because it's a pipeline.
Right, yeah.
So, and I very much want to switch over. The big advantage is file transfer speeds with sockets is super fast compared to Windows file sharing, especially coming from the hospital. So we have a new mass spec in the hospital, and literally there's no way to automatically process that data without this Java program. I was actually physically, I set up a BitTorrent sync to just sync the files, and then I was just manually editing the sample queue. So it's just not.
I was wondering what that torrent client was about. Okay.
Yeah, BitTorrent sync is awesome if you haven't tried it. So, all right, cool. I think that's the best plan. So I guess we'll go from there. I've video recorded this session, so I guess I could post that on Vimeo for you, Judson, and link it up. Send you the link.
That'd be great.
That way you can reference it as you're running into us. I mean, this is sort of a side project. Your main project is your pathway prediction, your GSEA stuff, but I think you need to get your hands into the infrastructure as well. So it'll be helpful.
Cool. Yeah, well, thanks so much for taking the time to go over this with us.
Yeah.
Oh, no, not a problem.
Naveed,
Not the slightest.
This
is my project.
All right. Cool. All right. Sounds good. Well, I for one am tired and would like to go to bed. So I'm gonna sign off. But yeah, it was just awesome to get all this done. So I guess I'll be talking to you guys later.
Cool.
All right, sounds good.
All right.
Nice, guys.
Okay. Good night. Bye.